A study found that 80% of people exhibiting common influenza symptoms recovered without taking any medication. A random sample of 30 people who had developed influenza symptoms was taken. Let X denote the number of people in this sample who recovered without taking any medication. Is X discrete or continuous? Well, I think we can confidently say that it's discrete. We're dealing with a number of people. So definitely discrete, not continuous. So we have a fixed number of people and a constant probability of success. That means that we're dealing with the binomial distribution, and we can say there's 30 trials because there's 30 people, and a probability of success of 0.8. And we want the mean and standard deviation. So for the mean, we do 30 times 0.8, and that's 24. For the variance, we do 30 times 0.8 times the probability of failure, 0.2. So that's going to be 24 times 0.2. And that gives us 4.8. So the standard deviation is the square root of 4.8. So square root of 4.8, which we'll say is 2.19. Correct to 2dp. What is the probability, correct to 3 decimal places, that exactly 25 people recovered without any medication? So that's going to be a binomial PDF, just a single value, and we want 25. Number of trials is 30. Our probability of success is 0.8, and that gives me 0.172. So the probability that X equals 25 was equal to 0.172. And now we want at least 24 but no more than 28. So that's the probability that X is greater than or equal to 24, less than or equal to 28. So this time that's a binomial CDF going from 24 to 28 with 30 trials and success 0.8, and that's 0.596. Trial groups of 30 people from each of 15 different suburbs were then surveyed. Let Y bar denote the mean number of people per trial group who recover without medication. So now we're looking at a mean, and that suggests that we can use the central limit theorem, and that means we're going to have a normal distribution for Y. Now, these are our groups of 30 people, and we're doing it from 15 different suburbs, which suggests that n is equal to 15. Now remember, the mean will be the same as it was for the binomial, so that's going to be 24. The standard deviation will be the original standard deviation. I've got the calculation just here, but we need to divide that by root 15. So I'm going to say that that's 2.19 divided by root 15 squared, and so I'm going to say that's a normal 24, and it's 0.566 squared. We now want the probability of y bar being more than or equal to 25. So we can do that on the calculator. We have a normal distribution, and we're going to go from 25 upwards, and of course there's no limit with this, so pop infinity in there, and our sigma is the 0.566, and our mu was 24, and that gives me 0.0386. We now want to determine a 95% confidence interval, corrected 3 decimal places, for the population mean number of people per trial who recover without medication. So it's going to be between 24 plus, and we want a k value here. Now, for a 95% confidence interval, you may know that that's 1.96. If you're not sure about that, you can find it using an inverse normal. Put the tail setting to left. If it's 95% in the middle, there'll be 2.5% at each end. So that's 0.025 as a probability, and then we get 1.96. So that's where that comes from. So we're going to go for 1.96 times the standard deviation, which we've still got at the top of the calculator here, the 2.191, divided by root 15, root n. And of course over this side you've just got the same thing but with a minus in the middle. So 1.96 multiplied by 2.191 over root 15. But you can actually use the calculator to get at this. Now we can do the confidence interval on the calculator. So if we go for interval and we want variable, confidence level we put in as a decimal, 0.95. Our standard deviation is 2.191. Our mean was 24, and we know that we had 15 as n. And then we click next, and it actually gives us our confidence interval. So that's 22.891 at this end. And at the other end, that was 25.109. The researcher who conducted the trials in the 15 suburbs calculated a mean of 25 people who recovered without medication per trial. The researcher concluded that a smaller percentage of influenza sufferers take medication than had been assumed. Does this mean support her conclusion? No. 25 is within the confidence interval that we calculated before.